Another right here in the middle, 45. So this is alpha now. Alpha equals 45 degrees. What do I know? So if alpha is 45, what do I know about this angle right up here? If this is 45, what do I know about this one?
45.
Very good, also 45. So then I will remove that triangle from there just to enlarge it. If this is a right triangle and this is 45 degrees and this is 45 degrees, and I know how much is this? 1. It's the hypotenuse in the unit circle. Then this number, the measure of this leg, and the measure of this leg must be equal, because I know that any triangle with same angles must be an isosceles triangle. If the two angles are congruent or equal, the two sides have to be. Good. So can anyone give us the Pythagorean theorem now in this triangle? One equals? I have a, so I have to square a to apply the Pythagorean theorem, right? So it's a squared plus a squared. I have a and a, right? So then 1 equals 2a squared. I have to solve for a squared, and I get 1/2. I have to take the square root, and I get a equals plus or minus 1 over the square root of 2, but I have to rationalize by the square root of 2 and the square root of 2. So a equals plus or minus the square root of 2 over 2. However, I cannot use negative because 45 degrees is in the first quadrant and both x and y have to be positive. So I'm going to say in this case a equals the square root of 2 over 2. So if this piece is the square root of 2 over 2, maybe I should have used a different color, sorry about that. So if this piece is the square root of 2 over 2, how much is this piece? Right. And again, how much is this piece? 1. So I'm ready for you to give me cosine. I'm sorry, I should have started with sine. It doesn't matter. So I'd like you to give me sine 45 degrees or pi over 4. And then cosine 45 degrees or pi over 4. So how much is sine of this angle? Opposite over the hypotenuse. How much is it? That's it. And how much is cosine of this angle, which is the adjacent over the hypotenuse? Square root of 2 over 2. I go back now to fill in my chart. What would you tell me to fill in these two cells? Square root of 2 over 2 and the square root of 2 over 2. Now, I want to show you a chart in your book. Which I like, because this is exactly what we need. We don't need everything else, because I'll show you how to determine everything else you need. So this is on page 537, and that's exactly what I just showed you. However, this is not needed. You should not add it to your list at all, because this can be determined in 10 seconds. So you do not need to memorize this line. So I only recommend this chart, this piece. This is fine, but there is no need to memorize it. Now, knowing this, you can ask me any trig function, let's say, for these three. You can ask me, let's say, find secant pi over 4. I'll say secant pi over 4. Secant pi over 4 is 1 over cosine pi over 4. And I know that cosine pi over 4 is the square root of 2 over 2. I will flip this, and it's 2 over the square root of 2, and I need to rationalize. So I have 2 the square root of 2 over 2. Oh, it's the square root of 2. You can say determine tangent of pi over 6. I'll say, tangent pi over 6 is sine pi over 6 divided by cosine pi over 6. And I know sine pi over 6 is the easiest one. Okay, it's 1/2. Cosine must be the other number, which is the square root of 3 over 2. I write the numerator. I flip the denominator. Oh, it's 1 over the square root of 3, and when I rationalize, the square root of 3 over 3. You don't need to memorize anything more than this little chart. Now coming back to this. You remember I asked you, give me the coordinates of this point. And you gave me the square root of 3 over 2. And you gave me 1/2, right? X and Y. So the square root of 3 over 2 and the height of 1/2. Now, can anyone tell us what is the first coordinate? Of course, it's X. What is the second coordinate? Of course, it's Y. But what does the first coordinate represent? Yes, the first coordinate is cosine because cosine is measured on the x-axis. And the second coordinate is sine because sine is the opposite, so it's measured on the y-axis. So this is always cosine alpha and then sine alpha. So anywhere on the unit circle, let's say here, for this angle, I'm going to call it P, another point P, and this is angle beta. The first coordinate will always be cosine beta, comma, sine beta. Meaning, how long is cosine? This is cosine. This piece is cosine beta. How long is sine, or how much is sine? This piece. This piece is sine beta. Which makes sense. X comma Y. X comma Y. And now I would like us to determine a few. See how this works. On page 545, in exercises 21 through 24, theta is an acute angle. No, I'm still looking for something on this, and then we can work on 21 to 24. I'm looking at 14. Cosecant. They're not giving me anything to work with here right now on what I'm doing. I have to make one up. Okay, then we'll go to the book. Let's suppose I'm asked to find cosine 2 pi over 3. First of all, I have to identify the quadrant, because I don't know where this ends. It's kind of hard with pi in it. But I know what this is. What angle is this? 60 times 2. So if this is 60 times 2 is 120. So I am 60 degrees short of 180. If this is 180, this will be 120. Or 2 pi over 3. Good. Can anyone identify the reference angle for us? This is the reference angle. Yes, so the reference angle is pi over 3. Okay, good. Now, where do we measure cosine? Because I need to know the sign of cosine. Where do we measure cosine? Yes, it's the adjacent, right? So we measure cosine here. So what will be the sign of cosine in the second quadrant if it's measured on the x-axis? It will be negative. So cosine 2 pi over 3 must be a negative number, and it will equal cosine pi over 3 because that's the reference angle. How much is cosine pi over 3? I know cosine pi over 3, first of all, is not the first angle. And I know that sine pi over 6 is 1/2, and cosine pi over 3 will be 1/2. Because I picture that little chart. Pi over 6 at the top, 1/2 the square root of 3 over 2. The last angle has to be reversed, the square root of 3 over 2 and 1/2. So how much is cosine pi over 3? It's reversed. Sine of pi over 3 is the square root of 3 over 2, is 1/2, with minus in front. Negative 1/2. Now, can I determine sine 2 pi over 3? Sine is measured on, it's the height, it's the opposite. So sine is measured on the y-axis. What will be the sign of sine in the second quadrant? Positive, correct? So sine is positive top, and cosine is positive to the right. Cosine is measured on the x-axis, so it will be positive on this side and negative on this side. Sine is measured on the y-axis, it will be positive above and negative below. So sine 2 pi over 3 will be positive, and it will equal sine of which angle? Same angle, reference angle, pi over 3. What if now I ask, okay, let's determine tangent 2 pi over 3. What does tangent equal to? Right? So I have sine 2 pi over 3 over cosine 2 pi over 3. I don't have to memorize this. How much is sine 2 pi over 3? Oh, I didn't finish it. I'm sorry. I didn't finish it here. So how much is sine pi over 3? The square root of 3 over 2. So tangent 2 pi over 3 now is sine 2 pi over 3 over cosine 2 pi over 3. And I have them right here. I only have to replace them. This is the square root of 3 over 2, and this is negative 1/2. So the square root of 3 over 2 over negative 1/2. And I copy the square root of 3 over 2. I flip 2 over 1 with minus in front, and it's negative the square root of 3. Questions? Now I would like to come back to the questions in the book. Let's say I have an angle in the unit circle, and this is alpha. This is how much? And this is how much? What do these two represent? For any angle alpha, this height, the opposite, when the hypotenuse is 1, this height is always what? Sine alpha. This piece is always cosine alpha. We know that from the fact that this point has coordinates cosine alpha, sine alpha. Now please apply Pythagorean theorem in this triangle, in this right triangle. Tell me what to write. Say it again. Yes, the hypotenuse squared, 1 equals sine squared of alpha plus cosine squared alpha. This is one of the most important trigonometric identities. It comes from the Pythagorean Theorem for any angle that is the same. And now I want to practice this on page 545. Okay, number 28. Sine squared of the angle pi over 10 plus cosine squared of the angle pi over 10 is. What do you think this equals to? Give it a shot. Any ideas? It's okay if you're wrong. Exactly 1. No questions, right? I'm just using this for the same angle. Must be 1. Sine squared of an angle plus cosine squared of the same angle must be 1. Good. What about 27? Sine squared pi over 9 plus cosine squared pi over 9 must be 1. Good. From this relationship, I'm going to copy it again. Sine squared alpha plus cosine squared alpha equals 1. Let's suppose I want to solve for sine alpha. I'm asked to find how much is sine alpha from this equation. What should I do first? I'm given this equation. I'm asked to solve it for sine. What should I do first? Sine squared plus cosine squared equals 1. What would you do first if you were asked, solve this equation for sine alpha? Say it again. Good. How do I do it? First step. Of course. Sine squared equals 1 minus cosine squared alpha. Of course. Now what should I do to both sides to get sine by itself, not sine squared? Of course. Excellent. Take the square root from both sides. So then I have sine alpha equals. I'm missing something very important, crucial here. Thank you. Square root of 1 minus cosine squared alpha. This is another very important identity. But what if I want to find cosine alpha? Can you figure it out? Let's say now I want to find cosine alpha, and I don't want to start from scratch. Is there any way to write cosine alpha from what I have here? Plus or minus, exactly. The square root of 1 minus sine squared alpha. Let's say we forgot how much is sine pi over 3. We forgot. But let's say we know cosine pi over 3. How much is cosine pi over 3? Remember, pi over 3 is not the first angle, it's the last angle. How much is its cosine? One half, right? Perfect. Let's say we forgot how much is sine. Which of these two relationships will I use to find sine? Pi over 3. Right? So first of all, it's in the first quadrant. I will not use plus or minus. It's just plus. Because pi over 3 is in the first quadrant. Sine must be positive. Everything is positive in the first quadrant. So I have 1 minus what? Minus 1/2 squared, which is the square root of 1 minus 1/4, which is the square root of 3/4, which is the square root of 3 over 2 as we knew. So if Sine is pi over 3 is the square root of 3 over 2. Cosine is 1/2. If cosine is 1/2, then sine is the square root of 3 over 2, as we knew from our little chart a few minutes ago. Where is my chart? I lost my chart. So sine for the last angle is the square root of 3 over 2. Cosine for the last angle is 1/2, reversed from the first one. Any questions? Okay, in problem 18, and then I'll stop. Last problem. Problem 18, on page 545, we are given sine theta equals 3 over 5, and we are given cosine theta equals 4 over 5. They want us to determine the other 4 trig functions. One trig function is tangent theta. What does this equal to? Tangent theta is sine over cosine. Let's write it. Sine theta over cosine theta. And I have the measures. Sine is 3/5 and cosine is 4/5. I copy the top. I flip the denominator. I simplify. And I get 3/4. If tangent is 3/4, can anyone give us cotangent, which I know is the reversed, or 1 over tangent? Yes, but if I have tangent, which is 3/4, the multiplicative inverse will be cotangent. What is the multiplicative inverse of 3/4? 4/3. 2 more. Secant theta, if it starts with S, is 1 over cosine theta, which is 1 over cosine is 4/5. All I have to do is flip that. And the last one, cosecant theta, which I know it starts with C. This must be 1 over, and that will equal 1 over 3/5, which is 5/3. So once I have sine and cosine, I can always determine everything fast. Tangent, cotangent, secant, cosecant.